Okay, today I'm going to walk you through the problem, how many 5-digit positive integers exist where the digits are non-increasing from left to right. So for example, 87743 and 10000 fulfill the requirements, but 78987 and 33429 do not. So let's start off with what we know. Okay, so just reiterating the information from the problem, we know that the number must be 5 digits using the digits 0 through 9, and that it must be non-increasing from left to right. So let's look at the examples they gave us. So those 78987 and 33429 do not fulfill the requirements. We can actually rearrange these numbers so that they do fulfill the requirements. So you'll see if we rearrange the first one to 98877 and the second one to 94332, that they will both fulfill the requirements. So we notice that every set of 5 digits can create one integer that meets the requirements. So now the real question is, how many ways can we choose 5 digits? Here, I'm going to introduce you to stars and bars. So stars and bars is a method to count ways to group objects. Our objects in this situation would be the digits, and it uses an illustration and a coinciding formula. So I'll show you how to do it. So drawing this out, you'll see that k represents the 10 possible digits or groups, and k-1 represents the bars separating each group. So if we were to use this diagram to represent the number 94332, we'd have 1 star in the 9 section, 1 star in the 4 section, 2 stars in the 3 section, and 1 star in the 2 section, and our number of stars would be n. So now I'm going to share the coinciding formula. If we were to choose the number of combinations of k-1 items from n plus k-1 set of items, it would be n plus k-1 factorial over k-1 factorial times n factorial. So here in our situation, k equals 10, which represents digits 0 through 9, k-1 would just be 9, and n would equal 5 for the 5-digit positive integers that we're creating. Let's plug it in. So 14 choose 9 would be 14 factorial over 9 factorial times 5 factorial. So the math is actually pretty easy if we write this all out. You'll see we can cancel out 9 factorial on the bottom with lots of the digits from the 14 factorial on the top. You'll see that 5 times 2 equals 10 and 4 times 3 equals 12. That way we're left with 14 times 13 times 11, and this would get us 2002. We're not done yet though, so there is an exception. You'll notice that this is every combination of the 5 digits 0 through 9. So that includes repeating digits like 99999, which was appropriate, 88888, which is appropriate, 77777, which is appropriate, and so on. However, 00000 is included in this, and that is not appropriate because that is simply 0, which is not a 5-digit positive integer. So our final solution would be 2002 minus our one exception, which would get us to 2001 integers, and that is the answer to this problem.